Let us begin Chapter 1, Section 2, Objectives. After you read these objectives, we can do these examples. So let's look at example number 1. Solve slope-intercept form of a line given the slope -4/5 and passes through the point 2, -3. So here you have a slope and a point, so we are going to use a point-slope equation. So y minus y1 is equal to m times x minus x1, and that is your point-slope equation. So now let's plug in our points. Here we have x1 and y1, and here you have your slope. So plugging in your points, you have y minus y1, which is -3, is equal to m, which is -4/5, times x minus x1, which is 2. So now let us distribute and simplify. Here you have a negative times a negative, which becomes a positive, and -4/5 times x is -4/5 x, and then -4/5 times -2 becomes positive 8/5. Okay, now you want to combine like terms, which means you're going to subtract 3 from both sides. So y is equal to -4/5 x. And here 8/5 minus 3 is equal to -7/5. And this is your answer, -4/5 x minus 7/5. Problem number 2. Solve slope-intercept form of a line given that it passes through -1, 4 and 2, -2. So now we first have to find our slope before we find our equation. So let's name our points. The first point is x1, y1, and the second point is x2 and y2. So the slope formula is y2 minus y1 over x2 minus x1. So the point of x2 is -2 minus x1, which is 4, over x2, which is 2, minus x1 is -1. So we have -2 minus 4 is -6. And here you have a negative times a negative, which becomes a positive. So 2 plus 1 is 3. Therefore, our slope is -2. So let's use our point-slope formula to find our equation. So again, remembering our first point here, so y minus y1, which is 4, is equal to m, which we just solved to be -2, times x minus x1, and x1 is -1. So now, distributing and solving, we have y minus 4 is equal to -2x. Again, a negative times a negative becomes a positive. So a positive times a negative is negative. So we're left with -2. Adding 4 to both sides, we have y is equal to -2x plus 2 is our equation. Moving on to problem number 3. We have a word problem here, so let's read the word problem. Piece of equipment used in a landfill has an original value of 100,000. After 2 years of use, the equipment is valued at 75,000. Letter A, if the depreciation of the equipment is assumed to be linear, find an equation to relate the value V of the equipment over time. So first of all, let us determine our points. So our first point here is an original value at time 0 is 100,000. And then after 2 years, the price is 75,000. So once we have our x1, y1, and x2, y2, we can go on and find our slope. So our slope again is y2 minus y1 over x2 minus x1. I'm doing that calculation. You have negative 25,000 over 2, which is negative 12,500. And that is our slope. So now our equation v is equal to m, which is our slope. So negative 12,500 t plus our original value of 100,000. Again, this is y equals mx plus b. This value is your y-intercept because your x value is 0. So now once we have our equation, we can solve letter B. What would the value of the equipment be after 5 years? So now here we are going to substitute our time of 5 years into our equation. So the value is equal to negative 12,500 times 5 plus 100,000. And calculating that, negative 12,000 times 5 is equal to negative 62,500 plus 100,000. And that value is equal to 37,500. So after 5 years, the value of that equipment is 37,500. Moving on to letter C. In how many years will the value of the equipment be 0? So now you're solving for the time. So solving for time means you're plugging the value of $0 into your V. So 0 is equal to negative 12,500 t plus 100,000. Solving for t, you are combining like terms, which means you are subtracting 100,000 from both sides. So here you are left with negative 100,000 is equal to negative 12,500 t. And dividing both sides by negative 12,500, you have negative 100,000 divided by negative 12,000 leaves you with a time of 8 years. So after 8 years is when your equipment will be worth $0. And that completes 1.2.